Well, hello, and welcome to Astronomy 100. In this particular segment, we're going to begin the topic of eclipses of the sun and the moon. In astronomy, there are times when the things that we look at in the sky are things that occur over a very lengthy period of time, maybe many, many years to complete an activity, or it's a particular object that you'll look at that is going to be in the same place every single night, and so there's no urgency to look at these objects. But there are rare occurrences in astronomy that requires you to witness a phenomenon by being at the right place at the right time to see the event. And eclipses fall into this category. Eclipses are something that in historical times were actually quite frightening to people. Many, many years ago, when the eclipses that were occurring, the people witnessing these eclipses, they didn't really understand why eclipses occur. They didn't really understand what causes eclipses. They didn't understand how to predict them. They seemed to come out of nowhere, and they seemed to be activities that would just frighten people because of their inability to predict them and their sudden occurrence. And the environment changes quite dramatically during an eclipse. We know of in ancient times how people feared eclipses, and when they would occur, they would believe that these were the acts of the gods, typically to punish the people of the earth. And so there were great efforts made to try to appease the gods so that eclipses wouldn't occur again. And so an eclipse was always seen as something very bad, and it was again displeasure by the gods. But the difference is today we understand why eclipses occur. We know how to predict them. We know the mechanics of an eclipse, and we know of safe ways to view eclipses. So today eclipses are celebrated. These are events that we like to inform the public about so that they can go outside at the right time and the right place to be able to witness these rare events and to celebrate them, as you see in these pictures here. I want to point out, though, that the people in these pictures are using a special type of filter that they're looking through to make it so it is safe to be able to witness an eclipse without damaging their eyes. So what we're going to concentrate on in this particular segment is why do eclipses occur? What is the mechanics of an eclipse? To understand eclipses, the first thing that you need to understand is that it is an event that involves a series of coincidences. And the first term that's important to understand is the concept of angular size. Angular size, by definition, is simply the appearance of the size of an object. And when you look at anything in the world around you, you are always seeing the angular size of something, the appearance of its size. And the angular size of any object in the world around you involves the combination of three different things. Here is your eye, and the object that you're looking at, we'll just say it's this spherical body, is some distance away from you. And the spherical body has an actual size, we'll call it the true size. But the view of this object, seen at the distance that it is, creates what we call the angular size. In this case, we're going to call it the angular diameter, since it's the diameter of the object that you're witnessing. And you can just imagine that if we increase the distance, make the object much further away, even though we're not changing the true size of the body, by increasing the distance, it makes the object appear smaller. If we make the distance closer without changing the true size of the object, it makes the object appear larger. So the appearance of the size of any object has to do with the distance of the object, the true size of the object, and of course that translates into how you see it. When it comes to eclipses of the sun and the moon, the first coincidence that's important to understand is that the sun and the moon, although they are truly different sized objects, have the appearance of the same size. And so when it comes to the sun and the moon, if we had the ability to see the full moon next to the sun in the sky, what we would perceive is that the moon would appear to be the same size as the sun, meaning they both have the same angular diameter. But in reality, the moon is actually a much smaller body, and the sun is actually a much larger body. And so the first coincidence involves the reality of their sizes compared to their distances. For instance, The sun is actually 400 times physically larger than the moon is. Meaning, if we had a disk of the sun, you could stretch 400 Earths across the disk, 400 moons across the disk of the sun. So 400 moons side by side, all the way across the disk of the sun. So the sun is 400 times physically larger than the moon. Now, for the two of them to appear to have the same angular size, what that means is that the sun has to be much, much further away from us than the moon is to make the sun appear to be smaller. And the coincidence is that the sun is 400 times physically larger in reality than the moon is, but it is also 400 times further away from us than the moon is. So when you adjust the distance to be what it is compared to their true sizes, the result is the appearance of the sun and the appearance of the moon will look the same in the sky. And if you were to look into the sky, you would find that they both appear to be about a half a degree in size. And a half a degree is a relatively small angle. If you were to go outside and to look at the moon, let's say, just to make it the safe body of the two to look at, you could stretch your hand all the way out at arm's length, and you could take any one of your fingers and have the ability to cover the moon with just the tip of your finger there. So the tip of your finger seen at arm's length is about a half a degree. Now, in reality, what we have is a situation that can be broken into multiple categories. We have the ability to see an eclipse of the sun, or we have the ability to see an eclipse of the moon. When we have an eclipse of the sun, what is happening is one body is blocking the view of another body. That's just what the word eclipse means. So the second coincidence involves requiring the two bodies to appear to be in the same place in the sky at the same time. So what we have is, on a daily basis, the sun has this very slow journey that it makes against the background stars. Now, don't confuse this with the rising of the sun and the crossing of the sky and the setting of the sun. What we're referring to is the appearance of the sun as seen against the background stars. Day after day after day is going to slowly move. And the path that the sun takes against the background stars over the course of a year is called the ecliptic. The moon, as the moon orbits around the Earth, has its own path that it has to take against the background stars. And that, again, is just simply how we see the moon in the sky and how the moon seems to be superimposed against the background stars. And night after night after night, the moon is going to slowly work its way against those background stars. So what happens, though, is that the path that the moon takes against the background sky is not the same as the path that the sun takes against the background sky. So the orbit of the moon and the ecliptic, the movement of the sun, are actually not the same path. But what happens is the moon's path crosses the sun's path as they appear to be against the background sky. So twice every month, the moon has the potential of being in the same place that the sun could possibly be because those two paths cross. So if it turns out that the sun happens to be where the moon crosses the ecliptic or crosses the sun's path, then we have the ability to have both objects seen to be in the same place at the same time as we see against the background sky. Now, combine these two coincidences together, the appearance of having the same size, each body, and the appearance of being in the same place at the same time. When we combine the two of those, what that creates is the ability for the moon to pass, to essentially block the view of the sun. You can have the moon be in the same place that the sun would normally be, but blocking the view of the sun from our point of view. So that's what we call a solar eclipse. During a lunar eclipse, what we end up having is the moon being on the other side of the Earth as opposed to the sun, which makes it so that the light from the sun that normally is illuminating the moon is being blocked by the Earth, and so therefore the moon has the appearance of passing into an eclipse. And we'll talk about that in a future segment. So that's all for now. In a future segment, we'll talk about how the mechanics of a solar eclipse occur, the mechanics of a lunar eclipse occur, and we'll sprinkle in some pictures to show you what it would be like if you could witness one of these events. So we'll see you next time.